In this video, we will learn how to perform some descriptive analytics for univariate ungrouped quantitative data. So here's my example data, order amount. It's univariate, it's quantitative, and it's ungrouped. This is just a label field, this is not a data column. So we will learn how to use Excel to compute the various summary measures, the measures of central tendency, measures of variation, measures of location, and measures of shape. So there are some Excel functions to compute these measures, and we will learn those. Before we start typing these functions, the first thing we will do is we will give a name to this range. So we have selected this range of values. We're going to right click, and then we will click on define name, and it is prompting a default name called order underscore amount, and it picked up this name from this label here, so we will accept it. So this name refers to the range D4 through D28, D4 through D28. So this way, instead of having to type D4 colon D28, we will just type order amount. So the first thing we will do is calculate the sum using the Excel's sum function, order amount. Then we will count the number of values using the count function, order amount. So there are 25 values. Okay, now we will learn Excel functions for each of these summary measures. Mean, the Excel function is average, order amount, 554. Median, there's a function called median, order amount, 420. Mode, there's a function called mode, order amount. Population variance, var.p, order amount, 110110. There's another function for population variance called var.p without the dot, order amount. Sample variance, just var, order amount, gives us sample variance. Or we can use var.s, order amount. Same thing. Population standard deviation, stdev.p, order amount. Another variation, stdevp, order amount. Same answer. We can also do square root of population variance. We'll get the same answer. Standard deviation for sample, stdev without the s or dot s. If we just have stdev, order amount, we will get the sample standard deviation. Or we can do stdev dot s, order amount, we get the same answer. Or we can do square root of sample variance, and we get the same answer. Now range and interquartile range, before we compute these, we have to compute these. So max, there's a function called max, order amount, 1475. There's a function called min, order amount, 125. There's a function for first quartile, equal to quartile, order amount, comma 1 for first, 310. Second quartile, equal to quartile, order amount, comma 2 for second. And the second quartile value is identical to the median value. Third quartile, order amount, comma 3, 725. fourth quartile, order amount, comma 4. And the fourth quartile matches with the max value. Percentile, here we'll figure out the 60th percentile. So equal to, there's a function called percentile, order amount, comma, for 60th percentile we will type 0.6. Skewness, there's a function called skew, order amount, that's it, 1.245. Kurtosis equal to Kurt, order amount, 1.145. So that's how we compute these various summary measures using Excel functions. Oh, we forgot to do range. So now that we figured out max and min, we can do max minus min. So that's the range. Interquartile range is third quartile minus first quartile, 725 minus 310. Okay, now we have completed all these measures. So for some of these measures, let's learn some alternative ways. So for example, for the mean, what's an alternative way to compute the mean? It is a sum divided by the count, 554. Median, is there an alternative way? Yes, if we copy this, let's say here, and we sort it from lowest to highest, data, sort, smallest to largest, and then find the middle value. So there are 25 values, so the 13th value is a middle value, 420. So the median is 420. Mode is 400. So let's see, do we see repeated values? So 125, 175, so the frequency of 125 is 1, frequency of 175 is 1, 1, 1, 1, 1, 1, 1. 400, there are 3 of those, so the frequency is 3. 420, the frequency is 2. 1, 1, 1, 1, 1, 1, 1, all the rest are 1. So the frequency of most of these values is 1. The frequency of 420 is 2. Frequency of 400 is 3. So the mode is 400 because it has the maximum frequency. How to compute variance using another way? Well, we compute the deviation from the mean. So what's the mean? 554. So the deviation of each of these values, so deviation of this from the mean, 16. Now I want to copy this formula down all the way, but before I do that, I have to do some adjustment in this formula. So D33 is a value for the mean. Now I want to put a dollar sign in front of 33 so that when I copy this formula down, the 33 stays 33. It does not become 34, 35, etc. But the D4 will become D5, D6, D7 and so on, which is what I want. So I'm going to copy this. So some deviations are positive. So all the values that are greater than 554 are positive. The deviations are positive. And for all the values that are below the mean, the deviations are negative. And in theory, the sum of these deviations will be 0. So if I want to do the average of this column, average will be 0. So it's no good. So what we do is we square deviations from the mean. Basically just square this value. And now take average of these values to get the variance. So the variance is average of these values, which is basically the sum of these values divided by the count, same value, and that's what we had here. So that's the population variance. How to get the sample variance? Sum of these values divided by count minus 1. Count minus 1. And once we have this, we can do square root of the population variance to get the population standard deviation, and square root of sample variance to get the sample standard deviation. So these four answers are identical to these four answers which we obtained using a completely different approach. Okay, now we have another set of data. If you just copy and paste that onto here, all these formulas will be recalculated. All these are recalculated. The only thing that did not get recalculated is this, and we did not do this column. So data sort. So the median will be the 13th value, 1640. Mode 1475. Let's see, 1475 appears 3 times. No other value appears 3 times, so that's why the mode is 1475. So that completes our lesson on how to do descriptive analytics for univariate quantitative data, at least how to do the summary measures.